Parallel lines have so much in common, it's a shame that they will never meet. Today, we are doing a lesson on parallel lines. So, a couple of things that I want to remind you about parallel lines is that parallel lines all go in the same direction. And so, because they go in the same direction, the slope is always the same. If they are parallel, and they are not on top of each other, then the slope is the same, but the y-intercept is different. Now we're going to talk about situations where we have different systems and solutions. Right now, we have no solution. So when we have no solution, it would mean that we have two lines and two lines will never meet. So an inconsistent system means that there's no solution. The lines never meet. And the only way for lines never to meet is if we have parallel lines. That means we have the same slope, but a different y-intercept. Now, this equation here, we know this is y is equal to negative 3 over 2x plus 5. We know that the slope is negative 3 over 2, and the y-intercept is equal to the 5. And since the only way it's possible for us not to have a solution is to have the same slope and a different y-intercept. We could write any equation that has the same slope and a different y-intercept. So I could say y is equal to negative 3 over 2x plus 6. It has the same slope, but a different y-intercept. Now, we have dependent systems. When I talk about a dependent system, it would mean it has a solution. Now, there are two different ways that we can have a solution. We could have infinitely many solutions, or we could have just one solution. Right here, we have the equation of y is equal to negative 3 over 2 plus 5 graphed below. A dependent system is a system where a solution exists. In this case, when we have infinitely many solutions, it would mean that we have the same line. Infinitely many solutions would mean it is the same line. So let's say I had another line and it was directly on top of this. So if I have exactly the same line, then I have the same slope and I have the same y-intercept. So there's only one possible equation that would give this infinitely many solutions, and it would be exactly the same equation. In this case, y is equal to negative 3 over 2x plus 5. You could write it in standard form, but ultimately, when you graph it, you would still have exactly the same line. Now, this time, this independent system only has one solution. In this case, it means that I have a line that has a different slope, and as a result, the two lines will meet once. Meaning we only have one solution. So let's say I have a line that looks like this. This line is y is equal to x. My original line, y is equal to negative 3 over 2x plus 5. You notice that the slope of the blue line is 1. The slope of the red line is negative 3 over 2. As long as the slopes are different, then the system will have one intersection. So, what's a possible second equation? It could be anything. Any equation of a line that has a different slope will give you one solution. So, ignore this. It shouldn't say no, it should say one. Any linear equation with a different slope will give you one solution. So, for example, we have y is equal to x, and this gave us one solution at 2, 2. Okay, this next example, we're not doing any graphing. We're just looking at proving this. We're going to look at the slope and the y-intercept, and we're going to determine the number of solutions that there are and the type of system. So let's look at our first equation. Equation 1, y is equal to 2x plus 1. So that tells us m, our slope, is 1. B, our y-intercept, is equal to 1. Let's look at our second equation. Equation 2, we have y is equal to negative x plus 7. So our m is negative 1, e is equal to 7. Now, since our two slopes are different, I know that this is a system that will give us one solution. Okay, so since the slopes are different, we know that the System will give us one solution. So the slopes are important because it tells us that the lines are not parallel. Let's do another example where we're doing the same thing. State the slope and y-intercept. Rearrange it to the y is equal to mx plus b form if necessary. So both of these are not written in y is equal to mx plus b form. Let's rewrite it so that it's easy for us to identify what our slope and y-intercept is. Okay, I'm going to divide everything by -3 so that we've isolated for y. Okay, let's clean this up. Y is equal to -5/3 plus 2/3x. Now remember, our slope, m, is always the coefficient of the term that has the x in it. So this is going to be my slope, and this is my y-intercept. Okay, so just a little note, slope is always the coefficient of the x term. So that being said, we have m is equal to 2/3 and b is equal to -5/3. All right, let's look at our second equation. I will put this in a little box. Okay, equation 2. 4x minus 1 is equal to 6y. Let's rearrange this. I'm going to rewrite it as 6y is equal to 4x minus 1. Then I'm going to divide everything by 6. So 4/6x minus 1/6. Now I haven't reduced this fraction to its lowest terms yet, so I'm going to need to do that. Y is equal to 2/3x minus 1/6. Now, that tells us my slope is 2/3 and b is equal to -1/6. We've got the same slope here. We have the same slope, but we have a different y-intercept. What that tells us is we've got two lines. They're parallel to each other, but they're not exactly the same line. And we know that because the b is a different number. For our conclusion, since the slope is the same, but the y-intercept is not, the lines are parallel and there are no solutions. Let's do another one. Equation 1. We have 4x minus 2y is equal to 6. Let's rearrange this. So we have -2y is equal to -4x plus 6. Let's divide everything by -2. So y is equal to -4 over -2x plus 6 divided by negative 2. That simplifies to y is equal to 2x minus 3. My slope is 2 and y-intercept is negative 3. Okay, our second equation, equation 2, 6x is equal to 9 plus 3y. Let's rewrite this. I'm going to move the 3y is equal to negative 6x plus 9. Let's divide everything by negative 3. Negative 6 divided by negative 3x plus 9 divided by negative 3. We simplify this, y is equal to 2x minus 3. So slope is 2, y-intercept is negative 3. In fact, we can see here that the two equations are exactly the same. So if we know that they're exactly the same, they're not only parallel, they're right on top of each other. Now, the proof that we have of this is because we know that the slope is the same and the y-intercept is the same. So we can say there are infinitely many solutions because, oh, and we know this because the slope and the y-intercept is the same. They are the same equation and the same line. So I'm going to give you a moment to try this on your own. And when you have rewritten the slope, this in slope y-intercept form, write a second equation to make it independent. Write a second equation to make it dependent with infinite solutions. And write a second solution to make it an inconsistent solution with no answer. Okay, let's take this up. I'm going to first rearrange this. The 7y is equal to negative 2x plus 14. We have y is equal to negative 2 over 7x plus 14 over 7. Y is equal to negative 2 over 7x plus 2. So what that tells us, our slope is negative 2 over 7, and our y-intercept is 2. Okay, so we know that for it to be an independent system where we have one solution, we need to have an equation of a line that has a different slope. So in a different slope, we could have 1 over 2x plus 8. This is an example of something that is going to give us one solution. You can write any equation you want as long as it does not have the same slope. Okay, write a second equation to make it a dependent system with infinitely many solutions. The only way for us to have infinitely many solutions is if we have exactly the same line, because then the two lines are touching at every single point on the line. So the same line would be y is equal to negative 2 over 7x plus 2. Or if we wrote it in standard form like this, we could have 2x plus 7y minus 14 is equal to 0. Hey, lastly, write a second equation to make an inconsistent system where we have no solutions. The only way that we can make it have no solution is if it's a parallel line. Okay, so it must have the same slope, but it needs to have a different y-intercept. The slope that we're working with is negative 2 over 7, and we need a y-intercept that is not 2. So I could say plus 3. For homework, work on these questions in your handout.